So this is my 11th lecture in this series. In this, I am going to discuss about how to deal with the missing data. In the previous lecture, I have explored some data with missing values and some statistics, all those things we have seen. Now, if we have missing data or null values in the data, how to deal with them. Okay, and here it contains bad data also, but I will talk about the bad data later. So in this lecture, I am going to deal only with the missing values, and I call this as a part 2 under this category. So let us start directly. I will start with the program here because theory part also parallelly I will be discussing wherever needed. So let us start the programming session with Spider. So I have here I am importing the pandas and NumPy and importing OS also because I want to keep the current directory as fixed. So this is my current directory, and in that one I have the data file, CSV file called Walmart sales dataset modified small. So originally in the previous lecture I used the full columns and full rows. In this one I have trimmed the dataset to form a smaller size. So let us see what is there in this dataset. So step by step I will show. So this is what now the given data is transferred from the file to data frame DF, and let me show the shape of that one. What is the shape of this? This is 100 by 5. 100 rows are there and 5 columns are there, and let me print the header, first 3 rows of the header. So from this you can see that there are 5 columns, means 5 attributes. One is date, other one is weekly sales, temperature, fuel price, unemployment. So except this first one, other things are arrays with all numerical values. The weekly sales to unemployment, these are all numericals, and of course this is also numerical, but it is an object. It is not an array. Okay, so whatever we are processing, probably, for missing values we will check everywhere. And let me show this data set as usual. So here, this is what we have. So this is what we have, the columns. And there is a missing value. In the temperature I have a missing value here, and in unemployment there is a missing value here. In date everything is okay so far, and here another missing value, temperature, here another missing value under unemployment column, and if you see other things again. So I have removed the values and I made it missed values. Consciously I vacated these cells and I made it missed values, but only in 2 columns, that is temperature and unemployment. Okay, so temperature and unemployment, these 2 columns have some missing values here, and let us try to process this using the Python pandas data frames. Okay, here that's why you got the shape here, 10 by 5. And what are the row labels here? Row labels, it is a range basically starting from 0 to 99. Then what about the column labels? Column labels are nothing but date, weekly status, temperature. These are whatever we have seen now. And let us see some information about this. So here, if you see the information, because this info method I have already discussed, in this info method, date is 100 non-zero values, non-null values, temperature 96, that means 4 values are null values, and unemployment 95, the remaining 5 are null values. Okay, so total how many null values are there? In this one 4 and in this one 5. Total 5 plus 4, 9. There are 9 null values are there in this data set. So let us, just for completeness, print the number of unique values here. So date contains 100 unique values, weekly sales 100 values, and temperature only 96 values, and here unemployment is 8 values. This is 98 values. Okay, so these are unique values are 98 here. Okay, so some things are, another 2 are repeating values basically. Here the unique values are 8. That means many things are repeating here. So this, any of the total 100 values are distributed in this category, and probably among these 8, null value or nan is also there. Probably temperature also, there must be some nan values here. Okay, so that is what we have, and this is again same thing. Null values are not a number, both are same in the data frames when you deal with in Python. And so here let us describe, and we describe, we have this kind of thing here. Okay, this is what just for completeness. Now let us consider the column temperature, and if you see the unique values, what are, earlier you have seen number of unique values. Now I am seeing the unique values. In these unique values, nan is also one unique value, because we have consciously introduced the missing value in some of cells in this column. So it is replaced with nan by default. So this is showing it as nan. So nan is also one category. Similarly, if I take the unemployment column, so in this also we have one nan here, but 1, 2, 3, 4, 5, 6, 7 values are there here. In these 7 values are there. Among the 7, 7 plus 1, nan, 8 values are there, 1 is nan. Okay, so these are the unique values. Now let us process this data. And here what I am doing, as I explained in my previous lecture, what I am doing is I am trying to find the indices of the rows which have missing values in any of the columns. Okay, it can be first column or last column or middle column, it doesn't matter. So that is what we are going to find here through this, and that is what is, I have executed this. When I executed this instruction, I got the indices. So let us see what are these indices. So these are the indices. So where there are actually 0 to 99, 0 to 99 actual indices, and wherever this condition is satisfied, that means wherever null is there true it comes, that is 4th row and 96th row and 98th row, etc. There are null values. Wherever there is a false, there are no null values there in that position. Okay, so I am using this Boolean vector. This is nothing but Boolean vector. This Boolean vector I am using as index, and Boolean indexing I am using on the data frame df, and I am taking only those rows with those indices. That means I have the missing rows in this one. Okay, so I am the missing rows. I am printing these missing rows here. So if you see here, so how many are there in this? 1, 2, 3, 4, 5, 6, 7, 8, 9. 5 plus 4. Earlier we have seen by using info method. In that one it has shown 4 plus 5. Total 9. So these are the 9 here. And in this one, if you see, only temperature is there. Temperature, nan is there. 1, 2, 3, 4 nans are there. under temperature, and under unemployment, we have 1, 2, 3, 4, 5 nans are there. Okay, so this is what we have, the actual. So what I have to do, I have to treat these nans. One method is, you can drop this row at all, totally remove this row, and you can remove this row, and you can remove this row, like that. All rows with nans you can delete. But here 100 values are there. Probably if I have 1 million values or 1 lakh values, removing some of the rows may not make much difference. But when there are 100 values, I cannot afford. When there are only 100 values with me, I cannot afford to remove 9 more rows. That means I will get only 91 rows. So I cannot afford to do that one. So dropping the rows, I will drop that idea. I will drop the idea of dropping rows. Okay. So what it means, somehow I want to utilize, I don't want to remove all these columns in this row. Okay. So because only in the temperature there is a nan, at other places useful data is there for me. So what I have to do, I have to replace this nan with some useful value. So one useful value can be the mean value here. You can have the mean value, but problem with mean is, okay. So let us, so problem with mean is, let us plot, let us say 0 to 99, because I have 100 columns. I am taking one column, some column I am taking, and I am plotting this. Let us say some variable x I am taking, and when I am plotting, let us say I am getting something like this. Okay, something like this. So here, I mean, not even this. This is not really representative. Let me erase this. I will again do it. So here, let us say I have some values like this. Let us say there is some value here, very high value, then and another high value here, and it could be even negative value also like this. So when I plot these values, probably I am getting this kind of things basically. Okay, this is the data. Actual data, when I plot as a continuous plot, I will get something like this. Something like this. Okay, this is the data. Now what happens? There is some spike is there. That means one value is outlier. You can say, you can call it as an outlier, and there is an outlier here. There is an outlier here, because most of the values are lying in this band only. Okay, they are lying in this band. So above this, these are all not needed. So if I take mean value, what happens is these large values, they will add up. These large values. When I take mean, this large value will add to this, and it will show as a larger minimum value, which is not correct. It is so when I am replacing the missed values with mean, what happens? I am hyping the mean value. Actual mean value is not that, because after I remove this one and this one and this one, mean will be somewhere here. This is the mean, not here. If I include these things, probably mean may go out of this line also. Maybe somewhere here it may be mean. Okay. So that means I am wrongly replacing the missed values. Okay. So that is not acceptable. So, and I am going to show that in the programming, not only the mean, mode is also not that much recommended. Basically, it depends on the data set. So it is not a good thing actually. Several times it is not a good thing. So best thing always is the median. So let us, so we can replace what I am saying. I can replace the missing values either with mean. What is that mean? Mean of the all values in the same column where the missed value is lying. Okay. So let us move to this. Let us see this. Here there is a missed value. So I have to take the mean value of all these things except this missed value. Missed value is nothing but nan. So exclude the nan, find the mean value, and replace that mean value with in this slot, in this cell. Okay. So if you want to replace with this, mean I can replace, or median I can replace, or mode I can replace. But as I told you, mean and mode are not recommended, and median is the popular one, and very safely you can use it. So that's why. But I don't do the mean. Let us replace with how to deal with mode also. In my code, I will demonstrate both using the median and mode. Okay. So let us come to the programming environment again. So this is what we have. I have in two columns, that is temperature and unemployment. These two contain the missing values. I have already printed what rows it has. So what are those rows basically? These are the rows: 4th row, 13th row, 27th row, up to 98th row, like this. Okay, this is the data. Now, so I don't want to destroy by replacing these things. So I want to be careful. So what I will do for this demonstration is I will copy this one. It is a deep copy. That means everything. Everything is copied from here to the another data frame. That is nothing but df1 as it is. Okay, it is a duplication. It is a physical duplication of the original data set. So df and df1 both are same, but in future I am going to modify this df1 so that I am preserving the original data set as it is. Okay, I will do all modifications in the df1 only. So let us talk about the median. So here what I am taking, I have taken the df1 here, which is my working data set now. df dot median. So this method I am using, pandas method. And here what I am doing, I am trying to find the medians not only for temperature and unemployment. I am going to find median for all columns. How many columns are there for us? How many columns are there? Numerical columns are only 4. The date is an object. So it will when we are finding the median, it considers only the numerical arrays. So only 4 columns are there. So this is 4 basically. So then skip. What are the options here? Argument options. Skip nans, not a number. So you have to skip. It is true. That means you have to skip. When you are computing, you find the median of remaining values excluding the missing values. And numeric underscore only. This field or option equal to true. That means you are finding only numerical. Sometimes what happens is in the here, see here, weekly says, of course in this all numerics are there. Sometimes the rows may contain some characters also, some alphabets also. In that case, there is an option for you to exclude the non-numerics and string kind of things or characters while calculating the statistic. That is rank statistic. Median is nothing but rank statistics. So this is what, these are the 2 options I have given. Now let me execute this one. So I have now all medians are there. All medians. See the console window here. So these are the medians. Weekly sales, this is the median. Temperature 69.475. Fuel price 2.986. Unemployment 7.808. So this is all columns I have found, but only 2 columns I have the this is 0th value, this is 1, index 2, index 3. So I have for temperature, that means index 1 and index 3, 1 and 3 at these locations I have the missing values, these columns. Okay, so this all, that's the reason I am reading this both. 1 and all medians is a vector basically, vector of size 4, and index first and index third. These 2 are I am reading into MED1 and MED2, and I am printing these 2, and this is 69.475, 7.808. It is same thing. It is here. Here also it is the same thing. See the console window. Okay, it is printing to both values here. Now let us. This is one way of finding. Let us look into another way of finding the median. As per your convenience, you can do it. Here, I am unnecessarily computing the two more. I need only two medians, but I am computing 4 medians. So it is not computationally beneficial for me. So that is the reason what I will do. I will take the DF1, the data frame with the column. This is column label, column indexing. So this is what I am taking, label indexing, and DF1 temperature column I am taking, and I am applying on the data, median data, and skip NA again equal to true. Okay, so here numeric only I used here. In this case, the numeric only it won't accept. Okay, because it is a single column. It is not the pandas data frame. Now it has become. It is not the pandas data frame. Pandas series it has come. It has come to series, and on series the numeric underscore only it won't work out there. Okay, so it is not. It won't accept. That's why this field I am skipping. In this method, I am taking the only one column at a time, and I am using the skip NA equal to true. The second option is not required. Okay, that's why I have removed here. So now let us execute this first one. So this is 69.475. Second median, it is 78. See the console window. Okay, so here you have the 67.495, 7.808. Okay, both are same. So now onwards, probably you need not use this kind of finding the medians for every column unnecessarily here, because only 4 are there. But in general, if there are sometimes 100, 200, 1,000 columns also will be there, and if you want to find the median for this, it is a computational intensive. So it makes no sense finding medians of all. So this method we will follow. We have to follow the second method, that is finding a median of a particular column. Okay. Now I found the median by MED1 and MED2 both are same. Whether I use this first method and second method, both are same. So this method, what I am doing now, DF1 dot fill not a number. It is a method. Fill not a number is a method. Fill NA, and I am considering the column. Okay, I am considering the column with the temperature label, and I am replacing all nans, all missed values under the column temperature with the median one, and all the missing values under unemployment with second median, that is median 2. That is how I have computed here, correct? So that is how here I have computed. So accordingly, the corresponding respective medians I am using to fill the missed values. Okay, so let me execute this one. I am executing, and after that, what I am taking. Okay, let me finish this. So I have executed this. Now the data frame DF1 with the temperature column is filled with median 1 and unemployment with median 2. Now there are no nulls. This is DF1. All nulls are replaced with the meaningful values. Okay, so let us see this. We know that indices missing rows. We already know that which rows are missing values. Okay, so I am using this as indexing, Boolean indexing, and DF1 I am printing. Okay, so DF1 when I print, I have not included this. This bracket is, I have not included this bracket. That's what it is. Right? Okay, so now you have this. If you see here, so 69.495 there was an AND. So let us compare with the original one. So original one also I will print here for comparison purpose. So this is what you have. See here. See here. So this is NaN original. This is the original one. The bottom one is the original one. That is DF. DF1 is replaced one. Okay, replaced frame. So in this one, NaN is replaced with 69.475. Second NaN is also replaced with same thing, and here also it is replaced with same thing. Okay. In the same way, here NaN is replaced with 7.808, and I have one more NaN here that is also replaced with 7.80. Then if I continue, there is in the last one there is a NaN here. I have replaced with this. Okay. So this DF1 data frame, now it contains full numeric fields, no missing values in this case. Okay. So this is what you have. If I replace with the median, so let us try to replace with the mode, for example. Let us see the possibility of mean. I am totally ruling out. Probably sometimes mode will make sense. So in that way, let us check with this existing data set. What I am doing here, again I am taking the column, temperature column. I am finding the mode, and same condition, drop NA equal to true. So in the previous one, you see the syntax there. There is some difference there. When you are using median, you use skip NA equal to true. And here instead of skip NA, it is replaced with drop NA. Okay, so you should be very careful because when you copy and paste the instructions, then skip NA won't exist for the method mode. So you should be very careful. So here it is equivalent one is drop NA. So this is what I used here. I made it to true again, and let us print the mode value of this here. So when I see the mode value, so actually this is the world one because here I got the mode. But in this case, for example, let us see this. See, I am starting fresh replacement. So what I will do, df1 equal to df dot copy. Again, deep copying I am doing. So total contents I am transferring again because because df1 is already corrupted now. I have modified that one. So I should not do any operation on that one. So original one again, I am copying to df1. So let me copy that first. Then let us find the mode 1 for temperature column. If you see here mode 1, see mode dot shape, it is giving 96. So let me print this mode 1. Mode 1 has 96 values, 0 to 95. That means this data won't contain specific mode. It is some data won't contain mode. Dominant mode is not there. Okay, so in that way, if it is oscillating like this, then you will get every point appears as a almost every point will appear as a mode. Okay, similarly, let us see this one. So in this case, mode, let us print the mode here, mode 2. So here 4 modes are there. Okay, here in the under for temperature column, we had how many? We had 96. This is what we had, 96 mode values are there. And for unemployment, we had 4. Those 4 are nothing but here. Okay, here 0 to 95 they are printed already. Okay, so these things probably not suitable even in this for this data. Not suitable really to use the mode because there is no single mode or double mode also. In the first case, temperature case, we have so many modes almost equal to data point. Every data point is a mode. So let us see the situation what is happening there. So what I am doing, I am trying to plot the column that is mode. I want to plot all 96 values of the mode here using the matplotlib package, and I am creating mode. I am taking as into y column, y vector on y axis, and on x axis I am creating 0 to 95 vector. Okay, now I am plot dot scatter plot with blue color. So let us see this one, and where is the plot here? So I have a plot here. Let me expand this. So I think previous ones are there. Let me close this first. All plots I am closing. Now I am again plotting this. So here I have this is so let me again execute this. Up to this I will execute. See my selection. Mode 1 I am taking 96 values. This is also not one. So here 96 values. Yeah, no problem. Mode. Then okay. Mode 1 I have generated. Mode 2 I have generated because they are two different variables. So I need not worry about that. Now import this. Create this again. Plot this. Okay. So this is what we have. So here what is there? 96 values. Every value it is plotting. So this is I have taken this is not the actual data. Data contained 100 values. Out of 100, 4 were nans. Those 4 I wanted to replace, correct? So this is the actual mode value. That means almost every data point is acting as a mode. So in this case, what I can do, best way we will see. Okay. So in this case, what I can see is I can probably, because there are 96 values, something like that, then I will take 96 values means, what is that? 96 values, 48. So for the middle value, for example, I can take middle value. So approximately I am taking the middle because this is the lowest values here, highest values here, some middle value I will take, and that value probably it will, if you want to use, okay, if you want to forcibly use just to get rid of the missing values, you can use this one. This may not be accurate, but it is probably it could be sometimes better than mean. So let us fill this one. I have filled this. So what is that I have done? I have filled the temperature with mode 48, and here mode 2 there were 4 values. Okay, I think I have not plotted that. So let me plot this also. So this is what? This is one mode, second mode, third mode, fourth mode. There are 4 modes are there. Maybe I can take one of these. This I can take middle values because this is 7.7, this is 7.9 somewhere. It is something like a median in these values. Okay, not exactly. So I have taken 48th mode 1 variable. Okay, 48th value of mode 1 variable, and second value means 0, 1, 2. Actually, the third value of the mode 2 I am using to fill the temperature and unemployment columns wherever the missing values are there. Okay, so I have replaced this and I am calling this as df1. So now again let us see this. Let us see df1. That means modified column. So let me close this. Then original rows with missing values. Okay. See here again these are filled. Earlier it was 69.475 something like that. Now it is different here now. Because I have taken the middle value, it is almost similar. It is appearing similar. Okay. 69.640, 69.640, 69.640. Okay. So in the same way here 7.83. It is coming same because I took the second value here. So it is not making much difference here. Okay. So it is almost equal to. So whenever you come across multiple modes or there are no modes, dominant modes in the data, probably you can, you can take some mode value which is in the middle of the interval that maybe you can use. Otherwise, best thing is you don't use mode at all unless you have specific reason for that, and you can go for median. Okay, so we have I have demonstrated the replacement of missing values with with median and mode. And here again, let me say, if I drop, what will happen? Okay. So let us say simple dropping. I told that you can, if the number of data points are more, you can simply drop the rows. Here I am dropping 9 rows. So finally I will be left over with 91 rows. Okay. Let me do that. I am copying again because already corrupted. Already corrupted is my working data set. So df1 I have taken, I have copied, and df1 I have dropped. These all the rows axis equal to 0. That means rows. I am dropping here. Dropping method I am using df1 dot this, and I am copying this to df2. Okay. So df2. So df2 shape I am seeing now. What happens? Let us see. So it is 91.5. Means 9 rows are dropped here, and if I see the info of this, what I get is this one. Okay, so 91 non-null rows, 91, 91, 91. So the remaining rows, 9 rows with missing values. The missing value may be in any of the row, in any of the column. But if one missing value is there in any of the columns, I am removing the total row. In that way, I got 91 rows by dropping this one. Here I cannot effort actually. 99 values I am dropping down means almost 10%. 10% of the 100 values I am dropping, which is not, which I cannot effort if it is values are small. Okay. So I think you understood the thing, whatever I am saying. And so this is what is the missing value of the data. Filling the missing values with one of the statistics. Mean is the average statistic, and median is the rank statistic. Okay. And of course mode is also, it is a average, it comes under average statistic. So here this is what we have done. So let us break here. I have shown you the demonstration of the programs, and so thank you for your attention for today's lecture. So in the next lecture, I will continue with my next lecture, other techniques of treating missing values or bad data. Okay. Thank you. Thank you for your attention.
Like, share and subscribe. Hit the bell icon for more updates.